This is CPM Precalculus Chapter 2, number 169. So here we have a function f of x is x cubed plus 2x, and g of x is defined to be 2 times f of x. Alright? So part A says to write out the function g of x. So we know writing it out just means to expand it. G of x we know is 2 times f of x, right? And that's the same thing as 2 times f of x is x cubed plus 2. So if I write it just like this, I am wrong. Why am I wrong? Because I have to make sure to put parentheses around the whole function right here, because the 2 is multiplied by the whole function, and the 2 gets distributed in. So that's 2x cubed plus 4. Okay? So this is part A. G of x is 2x cubed plus 4. Part B says to draw the graph of f of x and g of x on the interval -2 to 1. So what that's telling us to do is go ahead and draw the graph, right, of f of x we know is x cubed plus 2. G of x we know is 2x cubed plus 4. And we want to look at the interval -2 to positive 1. So going to the left, this is -2, positive 1 is here. We don't care about anywhere to the left here or anywhere to the right. We just want to look within this region. So I'm bringing out my calculator. I'm going to go ahead and push y equals, clear away anything that's there. So clearing those. I'm going to put y1 is equal to x cubed plus 2. Okay. Let me graph that first just to kind of get a general idea of what it looks like. It's just the cubic function shifted up 2 units, right? And then I'm going to graph also g of x is 2x cubed, right? And I'm putting that on y2 so they both appear, plus 4. So then I'm going to graph that one. And I see that at first I have one function, right? And then the other one. So let me go ahead and just concentrate on one of them. I'm going to clear y2. I push y equals to get here. I cleared y2 and I graph it again. This is just f of x. Okay. So what is f of x at -2? Right. So if I plug in -2, it's going to tell me. So let me go ahead and scroll. Let's move the calculator. Scroll to the right here. F of -2 equals, if I plug in -2 into f of x, that's -2 cubed plus 2. -2 times -2 times -2 is -8, plus 2 is -6. So here I have, I'm going to use a little smaller for my y-axis units. 1, 2, 3, 4, 5, -6. So here is my point at -2. And again, because I'm looking at the region -2 to positive 1, right? Inclusive means I'm going to bubble that in, and it's a closed circle. Okay, also I'm going to look at what's the output at f of -1, right? It's -1 cubed plus 2. I'm just plugging it in to this equation. That's equal to -1 plus 2. -1 plus 2 is equal to positive 1. So I'm going to go ahead and know that at x is -1, the output's positive 1. So I go to -1 and the output's here, positive 1. I'm going to get all points here. So on f of 0, right, f of 0, if I plug it in, it's 0 cubed plus 2 is equal to 2. So 0, I'm going up to this point, right? And finally, f of 3 is going to be 3 cubed plus 2. That's 27 plus 2 is 29. So at 1, it's all the way up here. Oh my goodness, I should have made my y-axis even longer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 3, 4, 5, 6, 27, 28, 29. So some are all the way up here, right? Is my I made a big mistake. What did I need to do? I didn't need f of 3. I need f of 1, right? So if you caught that, good for you. That's just 1 cubed plus 2. 1 cubed is just 1, so that's 3. Phew! I don't have to go all the way up. It's just to here, okay? So that would have been f of 3 over here at x is 3, but we are only looking at the region -2 to -1, okay? So then I'm going to connect these. I know the general shape here looking at my calculator, so it's going to be going from over here, it's going to curve and then start going up. Something like this, right? So this is f of x. Now I can go ahead and do g of x. Let's take another color, and I'm going to get the same point. So I want g of -2, right? G of -2 is just 2 times -2 cubed plus 4, and that's equal to 2 times -8 plus 4, or -16 plus 4 is -12. So at -2, the output is -12. Okay, so I can even graph that to see it. Okay, 2x cubed plus 4, graph. All right, so over at -2 now, I have -12, so I can go ahead and say like this: -1, 2, 3, 4, 5, 6. So I know it goes down 6 more. 1, 2, 3, 4, 5, 6. So that's -12, right? G of -1 now, let's plug in -1 into this equation, is 2 times -1 cubed plus 4. That's just -1 cubed is -1, so -2 plus 4. And that's equal to +2. So at -1, we go up to +2, right, here in green. G at 0, we know, is 2 times 0 cubed plus 4, which is 0 plus 4, or 4. So at 0, we're going up to 4. And finally, g of 1 is equal to 2x cubed, where x is 1. And that's 2 times 1 cubed is 2, which is 6. Okay, so 4, 5, 6. So at 1, we're going up to 6. And then I want to connect these points. Well, let me do a little better job. Whoa, it's hard to draw on this. Okay. Okay. So here, I mean, I didn't do a perfect job, but here you see in green is g of x, right? And in blue is f of x. All right. So let's get rid of our calculators, and that's what we see there. Okay. And finally, we want to use, so that's part B, was just sketching these graphs. Part B, we want to use our program to compare the areas under each of the curves separately. Alright, so what that means is we want to look at the area under f of x, which is this area, right, between the curve and our function. So f of x has some negative area over here, right, and positive area over here. And we also want to look at, I'm going to use yellow, to find the area under g of x, which is this area, right, and between the curve, remember it's between the curve and the x-axis, so it's also this area as well. Okay? So let's go ahead and write that out. Part C, let's use our program. So we want to look at, first of all, let's find the area beneath f of x from -2 to 1, right? So f of x is, let's scroll up to see where it's defined, x cubed plus 2. So that's equal to the area of x squared, x cubed plus 2 from -2 to 1. So let's plug that in our calculators, and we're going to get 3 different areas, right? We're going to get a left-hand area representation, I'll call it a sub L, a right-hand endpoint rectangle, right, a sub R, trapezoid, and I also added in my calculator a sub M, midpoint rectangle. Okay, so I'm going to actually get 4. So let's go ahead and use our calculator's program. So program curve area, enter, run that, right? Our function we know is just x cubed plus 2. Our starting index a is -2. Our stopping index b is 1. And number of rectangles, it doesn't say how many. So let's just use n. You could use any number. Let's use n is 20, okay? This is our choice. The bigger, the better, because the bigger, the more accurate our answer is. So let's say 20 there. We wait for it, right? And so a sub L is 1.558. I'm going to go ahead and write all these numbers. 1.588125 units squared. A sub R is 2.908125 units squared. A sub T, the trapezoid, is 2.233125 units squared. And finally, the midpoint rectangles is 2.2584375 units squared. Okay? So now let's go on to also compute the area under g of x, right, between the same region, -2 and 1. And that's the same as a, and we found in part A here, g of x is 2x cubed plus 4 between -2 and 1. And let's compute that. In our calculator, we're going to get a L, R, T, and now midpoint, right? So let's bring out our calculator, right? And let's run our program again, curve area. This time our function is not x cubed plus 2, but it's 2x cubed plus 4, right? 2x cubed plus 4. Oops, not minus. Let me delete that. We're starting at -2 still, going to 1, and I still want to use 20 rectangles. Okay, again, that's our choice, and the larger n is, the closer to the accurate value we're going to get. So a sub L now is 3.11625 units squared. A sub R is 5.81625 units squared. A sub T is 4.46625 units squared, and A sub M is 4.516875 units squared. Okay? So now this is asking us, what do you conclude? We found both areas for each of the curves between -2 and 1. What do you conclude? Well, remember f of x times 2 is g of x, right? That was how it's defined. It's just going to be g of x is transformed using a vertical stretch. But what do you notice here? The area under f of x, right, is smaller. Using left endpoint rectangles, it's 1.558125. And the area using g of x, or under g of x, is 3.11625. And what is the difference between these? Well, I think that if you multiply it, let's go ahead and check it out. 1.558125 multiplied by 2. And what do we get? 3.11625, right? You just multiply it by 2. If you didn't see this, go ahead and look at it longer or see if you can see a pattern, but you can now, like I'm telling you, that multiply by 2, right, times 2, and you get the other area under g of x here. Remember, this is g of x, and this is f of x. And we know g of x is equal to 2 times f of x. And also the area underneath g of x is 2 times the area underneath f of x, right? Pick any one here. Let's look at the midpoint. 2.2584375 times 2. Right, we get 4.516875. Right, so this is all multiplied by 2, and we get the area for g of x. Okay, so that's we conclude the area under g of x is doubled that under f of x, right? And that makes sense because g of x is equal to 2 times f of x. So we know now that the area under g of x between a and b, whatever region we look at, is going to be 2 times the area under f of x looking at that same region. Okay? So this is what we want to pick out from this problem is if our function is defined to be 2 times another function, then the area is also going to be 2 times that function's area. Alright? So that ends for us CPM Precalculus Chapter 2, number 169.